Hello everybody and welcome to this video. In today's video I will be explaining the rest of far future technologies, by which I mean everything that isn't an engine. So let us start with the antimatter fuel tanks, which come in one of 4 different sizes, and in fact one of them has 2 variants, which will be easier to show if I move the tanks like this. Okay, these are the antimatter tanks, which in my opinion are some of the most annoying and difficult to work with fuel tanks in the entire game. Specifically because, as shown by the Near Future Systems Manager, they consume a lot of electric charge in order to keep themselves contained. So this figure here, the largest one, refers to... Anyway, the 2 ones that consume 120 electric charge per second, that refers to this 5 meter diameter unit, and also this large 2.5 meter diameter unit. These, basically, this tank here, and this tank here, both consume 120 electric charge per second per tank in order to keep the antimatter contained. So yes, it's a lot. This smaller one only consumes 60 electric charge, which makes sense. It's half the size of this one or this one. These rings only consume 10 electric charge per ring, regardless of the size, and are fairly straightforward. And to be honest, the rings are the ones that will be used the most, as only the Frisbee antimatter engine actually consumes enough antimatter to warrant the use of the other antimatter tanks. The only other antimatter engines are the Cassaba, which, based on its innate ablator, has an upper limit on how much antimatter you can actually put in it, and that upper limit is equal to 1 ring. The Dirac, which is probably one of the I'd go as far as to say it's one of the worst engines in far future technologies, although it's far beyond the the near future engines, or indeed most of the other ones. But yeah, it's difficult to work with because it uses antimatter and fusion fuels like deuterium and helium-3. It's difficult to work with. So, but yeah, long story short, you'll probably be using the rings unless you're getting into really big antimatter engines and designing crafts with delta V's in the 3 million meters per second range. Okay, that was the antimatter tanks. Onwards to this, the chroma imaging spectrometer. This is basically a kind of fancy science experiment which consumes 1.5 electric charge. Yes, and when I say that, I mean when far future or near future technologies refers to a kilowatt, they mean 1 unit of electric charge. Yeah, this is basically a science experiment that locates resources in an atmosphere in conjunction with the space dust mod, which is a dependency of far future technologies and is included in the mod download. Okay, onto the Crane gamma ray spectrometer. This is a similar sort of thing. It's basically a science experiment. Well, actually, it is a science experiment and a scanner for specifically antimatter. Yeah, basically you're using this for setting up antimatter collectors, which I'll get onto later with the associated parts. Alright, onto the fusion reactors. The most useful, in my opinion at least, the most useful non-engines in the mod. They both operate the same way and have a bunch of different modes and features that are worth discussing. Ah yes, the loop. Basically you need a lot of radiators to keep, you need a couple of radiators to keep it cool. The large one, as I will show by changing the loop ID, uses exactly, only needs 2 heat radiators of the 6.5K size. Basically when you expand them they should look like this. So yeah, this reactor needs 2 of these radiators to keep it cool. Okay, the smaller one can actually get away with smaller radiators, specifically 2 of those. In fact, actually, no, you still need, you either need 2 small ones, which is probably be preferable for symmetry, or if you really want to keep part count down, you can use a single 6.5 one as yes, basically heat requirements of the small fusion reactor are half that of the larger one. Okay, time to explain some of the other features common to the reactors. Specifically, okay, charge rate bar. This basically refers to the amount of the rate, well correction, it refers to the rate at which electric charge is transferred into the reactor before it can be used, because fusion reactors, similar to fusion engines, require charging before they can be used. Specifically, the small reactor, which is 2.5 meters in diameter, or the same width as a Mark 1-3 command pod, or commonly known as the Apollo style command pod. The small one is the same width as that. It needs 8,000 electric charge before you can use it, and it takes 8 seconds to charge. The larger reactor is a significantly more power-hungry beast, requiring 20,000 electric charge and takes minimum of 20 seconds to charge, because they both have the same maximum charge rate of 1,000 electric charge per second. Yeah, charge rate, the number is literally equal to how much electric charge goes in every second. The only reason for having a lower than the maximum charge rate is if you are using like solar panels or a fission reactor as a backup to keep the batteries charged while you charge up the fusion reactor. Okay, another thing that I want to mention, the other important thing, is the fuel modes. The fusion reactors have 2 fuel modes, a deuterium-deuterium or a deuterium-helium-3. The main difference is, while the one with the deuterium-helium-3 mode will generate twice as much power as pure deuterium-deuterium, but it also consumes helium-3, which is expensive. Like for career mode purposes, you might want to consider using only deuterium until you've developed a sufficient infrastructure for extracting helium-3, which is something else you can do with far future technologies. Oh yeah, and even with the even at maximum output, the fuel consumption for deuterium and helium-3 is ridiculously low considering how much electricity you get out of them. Yes, fusion reactors are also on the heavy side, specifically 13 tons for the small one and 33 for the large one. And apart from, yes, they all have a couple of structural variations, like specifically the large one has an inline or a compact one, which just doesn't have a top node, as can be shown here, because I can't attach it to the top like this with compact, but if I go to inline, then I can stick it on the top. The small one is similar, except it has an extra one. It has inline, like normal, a compact, which is basically shorter inline, and another compact where it just doesn't have a top node at all. Actually, yeah, I can't stick the large one to the bottom of this one, but I can with this one. Okay, that's the fusion reactors. Now, onward to the Fissionables tanks. These are fairly straightforward. Let's start with the 5 meter ones, as these are the simplest. 5 meter ones. They come in two sizes. They only contain nuclear salt water for specifically the Neven nuclear saltwater rocket. And yeah, you get a lot of Delta V out of these. And also the somewhat smaller and more early game Heinlein, which, it's still getting good Delta V's, just not quite as impressive. Anyway, those are straightforward. You just stick them onto your vessel, and they don't have any special requirements. However, it's worth noting that they're really heavy. A single 5 meter one, fully loaded, is 132 tons. But nuclear saltwater engine itself is more than capable of pushing it. Okay, now on to the smaller ones, specifically these 2.5 meter diameter ones, which can also be attached radially, come in 3 sizes, and then the pure radial ones, which come in similar lengths to their 2.5 meter counterparts. In fact, they're actually slightly longer, but they've got lower capacity and are more suitable for attaching to trusses. And of course, these ones are different because they have 2 possible cargoes. They can either hold nuclear saltwater, which is the default, or they can take fissionable particles, which is basically the full name for the fission fragments, which like all of these tanks can be changed to a fission fragment one. Oh yeah, it's worth noting that in this form they are also significantly lighter. Yeah, nuclear saltwater is way heavier than fission fragments, but fission fragments themselves are only used by this one engine. In the entire mod, only the X7 Asimov actually uses fission fragments as fuel. No other engine in the mod uses this, so it should help. And as a result, you only need to use these when you're actually designing around this engine. Okay, that's the fissionable tanks. Onwards to the Vulcan nucleus smelter. This is a fairly interesting part because it is basically... yes, it is 4 different kinds of resource converter in one part. Specifically, one very heavy part. Okay, it's lighter than a nuclear saltwater fuel tank, But anyway, it's 4 resources. Most of these are basically for obtaining advanced forms of fissionables, and that is the main use of the reactor. However, it can also input a certain amount of, also inputs a small amount of ore to replenish a ablator. This is primarily for making use of heat shields and ablative nose cones, which can be found in the Orbit Portals Technologies mod. But its main use in far future is for the refueling of the cassava, which has a very large amount of ablator contained within its structure. Yeah, that's the main purpose of the ablator setting. However, it can also produce nucleus salt water at a moderate rate, suitable for which over a small period which actually works fairly well with both engines, as the Heinlein actually consumes, once I get the screen up, it actually consumes more nucleus salt water than the Neven, which honestly, Neven is just a direct upgrade to Heinlein, and of course the downside is more electric charge consumption, and the engine's more than twice as heavy. But then again, those downsides are trivial compared to the received output. So yeah, a Vulcan nucleus smelter actually has a nucleus salt water output per second higher than the consumption rate per second of the Neven, which is not particularly relevant, but I find it interesting. Oh yeah, also, nucleus saltwater one also consumes ore as well as the enriched uranium stored. You'll need ore tanks as well if you want to generate nucleus saltwater. And ore is also the only consumed fuel product when making a ablator. In addition, of course, to electric charge, and you need radiators to cool it down when in use. Fission particles, or generator, which it produces fission fragments for the refueling of craft powered by the Asimov. It also produces fission pellets for the refueling of engines such as the Cassava and the Vern. These are the 2 engines that use fission pellets, and are again the main purpose of actually having this converter. Okay, that's the Vulcan. It's fairly straightforward. Now onto one of the big converters, the Nova Antimatter facility. This is a part for the efficient generation, or inefficient generation, depending on which fuel you use, of antimatter. Okay, as you can see, it stores a small amount of antimatter in its own tank, and has 2 fuel consumption modes: light elements and heavy elements. Let's start with light elements. It can consume hydrogen and also a vast amount of electric charge. Okay, in order to actually use this without draining all of your vessels or bases, in order to use this without draining the batteries, I would recommend the large fusion reactor, the FX3 size. Simply because no other reactor or generating system can, well, I say that, no other generator works as well as this reactor for everyday use, although I am aware that if you stick enough solar panels onto your design, then that can generate the required power, especially if you're close to the whatever star you are currently residing in. Like, for prime example, the main sun in the stock system, sometimes known as Kerbal. Like, if you're at Moho's orbit, you need a lot fewer solar panels in comparison to, say, Kerbin orbit. But in general, you'd probably want to use the fusion reactor to power your antimatter generation. And it consumes the same amount of electric charge regardless of the fuel input, so I believe that is worth mentioning. However, on to the heavy element converter. The heavy element converter actually needs a lot of radiators. Like, specifically, it should need 2 of the largest radiators provided by the heat control mod, as I demonstrated earlier when I attached them to my fusion reactors. But yes, it's vastly more efficient, and you get way more antimatter for the same amount of electric charge. So if you have the option, try using fission pellets, which are stored in this straightforward fuel tank. Like, I say straightforward because it doesn't have any other requirements. You just stick it on your vessel and it stores fission pellets, or FIP as the resource indicator displays it. Yes, that's used for the Cassava and the Verne engines. Okay, so that's the heavy elements converter. It's more efficient than the light elements one, but the upside of the light elements converter is it uses liquid hydrogen, which you can just mine straight out of the ground, and it also doesn't produce any waste heat. So it's good for economy operations, or if you're in a situation where you can't stick the radiators onto the design, or more likely you don't have a way of keeping fission pellets. Okay, that's the antimatter factory in a nutshell. Onwards to the Hoover atmospheric ram scoop. This is basically a fancy air intake with 3 modes: a shock cone, a ram, and a circular intake. The shock cone, which is the default, is effective at any kind of speed and in any kind of speed. Long story short. The ram is technically better than the shock cone in terms of intake area, but it's only really effective at supersonic or hypersonic speeds. Then there's circular intake, which has the largest intake area, but only works really well at subsonic speeds. To be honest, I'd probably go for the circular one in general, unless you're, for example, trying to use this part to extract resources from the atmosphere of a gas giant such as Joule, in which case I'd probably go for a ram intake. Yeah, as for what they can actually extract, they've got a fairly diverse range, and the main resources of interest that can be extracted would be liquid helium-3 and also liquid deuterium. There are some other interesting resources that can be extracted, but in particular, I find the deuterium one to be of the most interest, simply because this is one of the only ways to actually extract deuterium, at least with the mods that I have installed. Okay, now it's time to show off some drills. Specifically, this Dust S regolith processing system, which it is deployable. And then there are these it's designed for the mounting on the front of a vehicle, whereas this larger unit is designed to be installed on the sides. Yeah, as you can tell, much larger. Like, yeah, it's like 2 of these units combined. However, the only real advantage of the side-mounted ones is, well, you can attach them to the side of a vehicle. Their main downsides are they're heavier, and they produce more heat when in use, and they're also less efficient. Specifically, they have half the efficiency of the smaller centrally mounted one. But since the only required input is electric charge, and this can be generated fairly easily, it is not too big of a deal. The central one also has half the heat output, and although it's the modded Far Future technology itself only adds compatibility for it's intended for the extraction of helium-3, although with other mods installed they support a large number of other resources, as shown by this long list of buttons here. Yeah, those are the... Oh yeah, the drills also have to be stationary or travelling at a very slow speed when in use, so these are perhaps better suited for a surface base or a similar stationary structure where you do not have to account for how much weight you're putting on the wheels. Okay, now on to one of my favourite parts for both its function and its appearance: the Buzzard particle scoop. Some watchers might remember seeing this particular part is actually the front or nose component on the ISV Encalagon that featured quite prominently in my cinematic video, The Undead Star, which some of you might be interested in watching. Okay, that was a bit shameless, but anyway. Okay, it has 2 mount settings. It has a standard one, which it looks like this, and then there's the inline one, which includes a truss structure which allows it to be included in the middle or even potentially at the bottom of a forward-facing craft. Unfortunately, you can't actually deploy it in the VAB, although it technically works equally well regardless of where you put it on the craft. I personally prefer the standard approach in using it as the front of my interplanetary vessel. It's got a large amount, it's actually got its own large amount of resources it can extract, and these cover the most interesting one it can extract here is Antimatter. This is actually one of the only ways to get it, apart from using the Nova Antimatter facility. It can also technically extract helium-3 and deuterium, along with liquid hydrogen and all these other resources which are added by other mods. But in practice, those don't tend to work so well, simply because those resources aren't usually present in a vacuum, which is the only environment where this works. Oh yeah, it also generates a certain amount of heat, and I would recommend changing the heating loop to something isolated from whatever loop you're using for your engines, if, of course, you're putting this on a craft which uses engines that need radiators. because the loop operates at a different temperature to to most other components, it would be helpful to have its own heating loop. Okay, and now for the final element of this tutorial, fusion fuel tanks. These can be attached radially and come in these 4 different sizes. Each size has 3 different fuel types: a full deuterium, a full helium-3, and a deuterium-helium-3 mixture, which is balanced in the correct ratio for the consumption by fusion engines. Like, if you're building a spacecraft that uses these as fuels, then that'll be when you primarily want to use the split deuterium helium-3 tank. Oh yeah, and to show you how, oh yeah, they all have a similar appearance for what's actually in which tank. This kind of light grey colour for deuterium only. This, I call it greeny bluey colour for helium-3. On these smaller tanks it's a mix of light grey and greeny blue, but on these larger spherical tanks the mixture is a very dark shade of grey. Yes, the tanks also have a couple of structural variations, which are purely cosmetic and don't actually change the function of the parts at all. This one has there's usually an inline for the exact width of the tank. There's a compact, which is just without the outside truss, and that serves these smaller ones. These large spherical tanks have 3 options: a full width, a half or 2/3 width, as this has a 2.5 meter mount and this has a 1.25 meter mount, and then they both have a compact, which has no additional truss structures whatsoever and is just the ends. Yes, that's... oh yeah, fusion fuel tanks also require electricity in order to keep the fusion fuel contained, similar to the antimatter ones. But the consumption rate is far lower and can easily be managed by simply using RTGs. Oh yeah, yes, now I want to talk, there's something I discovered that I thought was worth mentioning. If you have tweak scale installed, then using tweak scale to change the size of the tank doesn't actually change how much electricity is consumed by the tank in order to keep it running, in order to keep the antimatter contained. This is a bit cheaty, but I find it way too helpful for gameplay purposes to ignore it. Yes, that's something else that'd be the last thing that really needs mentioning. And with this, goodbye, and see you in the next one.